Hello everyone. I wanted to make a video for you. We didn't get to graphing logs. This was kind of the last topic in ALEKS for homework 13. So I just wanted you to have an option for some help if you needed it. Okay, so what does the graph of a logarithmic function look like? Um, Here I mentioned that it's the inverse of an exponential, but we didn't really spend much time on exponential graphs as well. So we're just going to go ahead and start graphing these. So this one here, this is going to be y equals log base 2 of x. That's the one that we're going to graph here. So the way that I want to go about this, um, is we'll just do old school X, Y chart and figure out what Y is for a few different values of X. And then we will plot those values and put them on the graph. All right, so a few nice values of X for us to choose here. I'm going to choose 1/2, 1, and 2. All right, so if X equals 1/2, then y is going to be log base 2 of 1/2. All right, log base 2 of 1/2 says 2 to what power gives me 1/2. And the answer is -1 because 2 to the -1 power is 1/2. A negative exponent gives you a fraction. All right, how about if x is 1? Then y would be log base 2 of 1. This says 2 to what power gives us 1? The answer is 0, because anything to the 0 power is 1. And then last but not least, if x equals 2, then y is going to be log base 2 of 2. That means 2 to what power is 2, and the answer is 1. All right, so I've got some ordered pairs here. When x is 1/2, y is -1. So I'm just going to kind of eyeball x equals 1/2, y is -1. When x is 1, y is 0. So we've got one at the ordered pair, 1, 0. And we have points at x equals 2, y equals 1, which is right here. All right. And then we can go ahead and connect the dots here. And it's going to look like this. So this is what log base 2 of x looks like. Now, this has a vertical asymptote here at x equals 0. It only approaches your asymptote on one end of this graph, and then it goes kind of off to infinity there on the other side, but it approaches that vertical asymptote here toward the bottom. All right, so what's the domain of this graph? What x values does this cover? Well, because that we have a vertical asymptote at x equals 0, we get really, really close to 0, but we never actually touch it. So I'm going to have an open parenthesis at 0, and then this arrow continues on forever up and to the right. Because it continues on to the right, we go all the way to x equals infinity. So our domain is 0 to infinity. And then the range on this, what y values are covered? Well, because this goes down forever, y values all the way to negative infinity will be covered. And this goes up and to the right. It's going to continue to go up and to the right forever. So our range is negative infinity to infinity. So that's what log base 2 of x looks like. And then we'll do the same thing for y equals log base 1/2 of x. So now what if our base is 1/2? Okay, again, we'll do an XY chart here. And we'll just pick some values of x. We'll actually pick the same ones, 1/2, 1, and 2. So if x is 1/2, then y is going to be log base 1/2 of 1/2. That says 1/2 to what power gives me 1/2? And that answer is 1. Next, we have x equals 1. So y is going to be log base 1/2 of 1. This says 1/2 to what power gives me 1? The answer is 0, because anything to the 0 power is 1. And then finally, if x equals 2, y equals log base 1/2 of 2. This one says 1/2 to what power gives me 2? And the answer is -1, because a negative exponent gives us a reciprocal, and 2 is the reciprocal of 1/2. All right, so we got some ordered pairs here. We'll put them on the graph. So we start at x equals 1/2, y equals 1. And then we go to x equals 1, y equals 0. And then x equals 2, y equals -1. We're going to have a similar shape as log base 2. It's just going to be upside down. So we are going to go through this way. And again, this one has that same vertical asymptote at x equals 0. And that's what y equals log base 1/2 of x looks like. This one's decreasing left to right, whereas log base 2 was increasing left to right. That's going to happen anytime you have bases that are similar. So log base 2, we're increasing from left to right. That's going to be the case with any base that's greater than 1. It's going to be increasing like that. And log base 1/2 of x is decreasing from left to right. That's going to be the case with any base that's a fraction between 0 and 1. And then what's the domain of log base 1/2 of x? Yep, same domain, 0 to infinity. And again, 0 is open because we never actually get to 0 because it's an asymptote. And then the range, what y values are covered here? Yep, you're right. It's exactly the same, -infinity to infinity. The domain and the range of both of these match. All right, so that's what our basic log graphs look like. And the other thing that we can do with these is going to be transforming them. So transforming these graphs, these are going to be the transformations that we are kind of responsible for. We might have a negative out front here. You might add or subtract an h inside with x, and you might add or subtract a k out here on the end. Now, we have previous programming from transformations of graphs, and everything here is going to remain consistent with our knowledge from before. So this plus and minus out front here, um, if you have a negative out front, then you'll flip this thing upside down over the x-axis. Right, that means you have a vertical reflection over the x-axis. All right, if you add or subtract a number inside the log with x, again, you're adding or subtracting inside the function with x. That's going to shift us left and right, and it's going to move the opposite way you think it will. So if you have x minus h inside, then that is going to shift you to the right h units. And if you have x plus h inside, that is going to shift you to the left by h units. And then I just want to make a quick note here. If you shift this whole graph left and right, so let's come up here. we will kind of look at these graphs. If we shift to the left or to the right, this vertical asymptote will move to the left or the right with the graph. So that's what I want to make a note of here. Your vertical asymptote moves left and right with your graph. So that's just something to kind of be aware of. And then finally, this k outside here, because we're adding outside to y, this is going to shift us up and down. And when we add to the outside, it moves the way you think it will. So if you have a plus k out there, that is going to shift you up vertically k units. And if you have minus k out there, that is going to shift you down by k units. Okay. And then one more quick note here. Order matters when we do this. We want to make sure that we do this in the right order. So the first thing that you're going to do is shift your graph to the left or right based on that H value. And then after you move things left and right, you're going to go ahead and do your reflections. And then the very last thing that you're going to do is any vertical shifting that you might have. All right, so let's go ahead and do one of these. All right, so we want to graph p of x equals log base 2 of x plus 5 plus 3, and then find the domain and the range. So I give you two graphs here. This is going to be kind of like for our work or our steps, and this one will be our final answer. Okay, so we've got some transformations happening here. But what's our graph going to look like? What's the shape of it going to be? We have to figure out what the base of our graph is going to be. Now, if we cover up anything that causes a transformation. So for instance, this plus 5 inside, that causes a transformation. So let's cover that up. And this plus 3 outside, that also causes a transformation. So let's cover that up. And so if we cover up anything that creates a transformation, what is left? Yep, y equals log base 2 of x. That's our base graph. That's that tells us what the shape of this graph is going to be, and then we're going to do any transforming to that graph. So I'm going to put our function back up here. And so we're going to start with y equals log base 2 of x. That was one of these that we started out with up here. So we had these 3 points on that graph. So I'm going to go ahead, put those on this graph. So we had 1/2, -1, 0, 1, and 2, 1. So there is our base graph. And this thing has a vertical asymptote at x equals 0. So I'm just going to go ahead and make note of that. Okay, and then what transformations do we have to do here? So this plus 5 out here, that's going to cause a transformation. What does that do? Yep, we're adding inside with x. That's going to go the left and right. That's going to go the opposite way you think it is. So that is going to shift us to the left by 5 units. And then this plus 3 out here, what's that going to do? Yes, it's going to shift us up 3 units. Now, remember, order matters, so we do have to do this in the right order. The first transformation that we're going to do is go left and right. So we're going to move left 5 units That's the first thing that we're going to do. So I'm going to take each of our points and go to the left 5 units. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here is our shifted graph. We went left 5 units, and notice that when we shift this graph to the left, our vertical asymptote goes with it. Our vertical asymptote is also going to shift 5 units to the left, which means our vertical asymptote is now at x equals -5. Okay, so we shifted to the left, and then what transformation do we do next? The only one left is to move this up 3. So I'm going to move each of these points up 3. 1, 2, 3, 2, 3, 2, 3. And so there is our graph. Now notice if you shift that vertical asymptote up and down, it doesn't really move. So it only moves when you shift to the left and to the right. Okay, so I'm going to go ahead and put these points on our final graph over here so I have a nice clean version here to work with. There is our graph. And we have our vertical asymptote here at x equals -5. So what's the domain and range of this thing? The domain of this graph, yep, the x values that are covered go from -5 to infinity. Notice this shifted with our graph. And the range, what y values are covered? Still -infinity to infinity. All right, I hope that helps with graphing and transforming logarithm graphs. Have a great day, and I will see you next time.